In this video, I'll demonstrate the installation and usage of a utility called VeraCrypt. VeraCrypt is a utility that is able to create and mount drive partitions from the contents of an encrypted file or entire encrypted drive. The primary items demonstrated in this video are download and installation of VeraCrypt, creation and mounting of a partition from an encrypted file, creation and mounting of a hidden partition within another encrypted partition file, use of steganography techniques to enhance the hiding of the encrypted file, discovery of any leaked secrets, creation and use of an encrypted system partition. The machine being used for this demonstration is a VM running on a QNAP TS453B NAS. This is a relatively low-end NAS with just 4 drive bays, 8 gigabytes of memory, and a single 4-core 1.5 gigahertz Celeron processor. The VM has an evaluation version of Windows 10 Enterprise, default installation of cygwin, plus the cygwin bin utils and proc psng packages. Cygwin is used in this demonstration to provide a set of Unix lookalike commands that are used in various situations during the demonstration. A folder with 2 multi-100 megabyte time-lapse videos. These videos are used in the steganography portion of this demonstration. A custom bash script named strings_match. This script is used to locate various secrets if they happen to leak from an encrypted partition. The custom script is shown here. It takes 2 arguments, as shown in this comment right here. The 2 arguments are, the first one's RE, which is a regular expression, and a path to a file to be checked. If the specified file contains any contents that match the regular expression, then the name of the file is printed with 4 leading and 4 trailing dashes, and then the matching contents of that match the regular expression is displayed after this eye catcher and file name. This script will be used to locate any leaked secrets by executing it once for every file on the system with the regular expression equal to a regular expression that matches all the secrets used in this demonstration. Ideally, the script will not find any matches and thus will produce no output. But if anything does leak that it's able to locate, then we'll see it in the output. Next step is to actually install VeraCrypt. VeraCrypt can be downloaded from this URL here, VeraCrypt. Note the .fr extension here. And we're going to download the Windows version, and if we're successful, we'll get this SHA-256 checksum. So the next step is to go on over to the virtual machine. Which I have right here. I'll use a browser here. And .fr. And it'll come up right on the top of this here, and we've got downloads. Okay. So we need to download the Windows version, because Simple little click and tell it to save. Now this is going to take a little while, so I will fast forward here to just before the download completes. The download is nearly completed. We have just about 10 seconds left. And once it has completed, we're going to confirm that what we have downloaded is what we expected to get downloaded. For right now, we'll just close this part. Note that we've got a padlock here, and we've got the domain name we were expecting. VeraCrypt and the FR is very important there. This is where we download it from, and we can pick up the expected checksum right here. The file we downloaded is the last one shown here. So we should get this SHA-256 checksum starts with D55C. This is one of the places where cygwin is quite useful. I'll bring up a cygwin terminal here quickly. And then all I need to do is type in SHA-256 sum. And we got, it went to downloads. And the file is right there. And this will generate the checksum on the file we downloaded. Note that it starts with the D55, just as expected there. And although there's a lot of characters, I do not see any characters that mismatch, begins and ends. Fairly good confirmation that we got the correct one there. So no longer do we need the browser. We're going to go execute. So under downloads, we've got the cygwin installation that I downloaded earlier during the setup, and we've got the VeraCrypt file that we just downloaded. Double clicking that. And here we've got it signed by VeraCrypt, and yes, we want to allow them to make changes. Okay, we've got English. Here, I've already read this license, and you'll need to also read it and confirm that you agree with all of this. But anyways, we'll go accept the license and next. Okay, so when I do an install here, put it in the default location. Okay. For now, and I've already gone through the tutorial, and that's why I'm demonstrating it here. Okay. And close the browser, and we now have VeraCrypt. Double clicking on it. And this is the dialog which we're going to use as we continue on in this demonstration. In this portion of the demonstration, I'm going to create and demonstrate the use of an encrypted file that contains a partition that you can use VeraCrypt to mount to any available drive letter. This partition is going to contain a number of secrets, and for later in the demonstration, I want to find any places where the secrets have leaked. And to do that, I'm going to use an eye catcher here, just a fixed string here of 4 equal signs, the word secret with a capital S, for trailing equal signs. And this will be used in various places as we create the information here. The encrypted file is going to be created under Documents with the name of volume 001, and then the default extension for it is a .hc. And the password for this encrypted file is a secret, so the password is going to be starting with for this demonstration, is going to start with the eye catcher, and then I've got a random 4-digit number here. Once it's created and mounted, I'm going to populate that partition with various secrets here. I'm going to mount it to the available letter, drive letter F, and I'm going to create a subdirectory called dir, has the eye catcher again, and then 2189 for the file name. And then within that directory, I'm going to create 4 different files through 4 different tools. Each of the files is going to start with the word file. It's going to have the eye catcher for a secret, and then it's going to have a random magic number to identify that file. And then each of these files is going to contain a different secret. The first 2 of these are going to be created through some standard Unix tools that are part of cygwin. The first one's the echo command, which is actually part of the bash shell, built right in. And then a very commonly used Unix Linux editor called VI. And then the last 2 are going to be created with some common Windows tools, namely Notepad and WordPad. So let's jump on over to the VM. Where'd he go? And he's left off where he was from the demonstration where VeraCrypt was installed. Then come down here to do create volume. I take the very first option here, and we're just going to do a standard one here. And then we need to give it a location to place the file. Oh, documents. And it's going to go at .hc. Okay. And we go here. Standard methods for encryption. Volume size, we'll choose 100 megabytes. Okay. Although you normally wouldn't do this because somebody might be watching over your shoulder for this demonstration, I'm going to display password. And the password is, again, we've got the easily to discover eye catcher. And then type the same thing. And once they match, we get the next here. Okay, and yes, it's a short, weak password for this demo. At this point here, it's actually creating the real 512-bit default password that it actually uses versus the password I typed. And it's collecting randomness from mouse movements that I'm doing here. You'll see the red here means it really hasn't collected all that much randomness. But very soon this is going to turn yellow, saying it's got a moderate amount. And if I stayed around here for a minute or so more, moving my mouse around in various random directions, I'd finally get a green here. For now, though, this moderate key randomness is fine. We hit Format. And it's going to create it fairly rapidly. Okay. Successfully created. Volume created. We go next. It's actually going to go back, and we could create another one. We don't need it. We just come back here. Next step is to actually mount that thing. So we're going to mount it as the drive letter F. Select the file. Documents. Volume right there. Open that, put it there, and then all we have to do is say mount. And then it wants to know the password to the thing. And it does take a little while to mount them, probably 20 seconds or so. So instead of time-lapsing the video, I'm just going to stay here, but it's going to get here fairly quickly. There we go. Now it's there. At this point, I can actually go look at it, see it, do whatever I want with it. So here we've got File Manager, and we can look at this PC. And sure enough, there's the local drive F. It's right there, and it's empty. To start out with, I'm going to use cygwin terminal. And I'm going to start populating this thing. So the first thing is to change over to that directory. And then I need to, as shown in the earlier slide, start populating. So first with the directory, I'm going to create it. Change on into that directory. Okay. And then the first thing we want to do is use the echo command to create a file with a secret in it. So echo, we're going to echo redirected on into the chosen file name, which is file. Okay, so I should now just be able to see the contents. I can display out the contents of that file. And that file contains that secret. The next one is to use VI to create another file here. So we're going to do VI. Okay, and then okay. Fortunately, I escaped out of the full size window in the VM there. Hopefully this doesn't cause me too much trouble because I did need to use the escape key. Gotta use escape to get out of VI. Unfortunately, it caused me to escape out of full screen mode also. But now I've got that there. Okay, I can go back into just the side over here is just some VM controls that I can use to control the VM that I'm using here. Similarly, I can do cat file. It's going to ask me for the number of that file. For the VI, that's 335. And that contains the secret that I showed on the earlier slide there. Okay, at this point, I'm all done with the Unix methods of creating some data. I can show those files are right there. Okay, for now. Okay, so now let's bring up Notepad. There we go. And then for Notepad, I need to have the eye catcher. 348. And then save that to the specified location as a text file. So let's go on over here, this PC. Got to get over to the F drive. There's the folder that I used Unix commands to create. And then within there, it's supposed to be file. Two, 448. All done with him. And oops, got on my terminal there. Okay. Next, I'll bring on up WordPad. Okay. File. Save as. PC, going over to my F drive, and we're going to save it in the rich text file format. That's going to be file 2557. Oops. Sorry. Go under the F drive there. Get to the right folder, have the file name there, and save it. Okay. So now I can look on the F drive. As a directory, and there are the 4 files that have been created. All done. At this point here, we can take VeraCrypt. Got the F drive selected, and I can unmount it. It's now gone. Bringing up File Manager again. Looking at this PC. F drive's no longer there. If I want to, I can mount that as a different letter. Let's take the H drive, mount. Again, we need the password. And the password being yep. Okay. As before, it takes 10, 20 seconds or so. It'll be done very soon here. And coming back on over, looking at the H drive. There's the secret again. And there are the files. Okay. So that concludes demonstrating the creation of a regular file that contains a partition that can be mounted to any of the available disk letters. In this portion of the demonstration, I'll be showing how to create a hidden partition, or what is sometimes referred to as a plausible deniability partition. These partitions are actually contained within another partition, a regular encrypted partition that we demonstrated in the previous section. But to actually get into the hidden partition, you use a different password. So when this is set up, when you go to mount this and it asks for the password, there's actually 2 passwords here. You can give one password, which is for the regular encrypted file, regular partition that we saw, or the outer partition. Or if you give the other password, you'll actually get into the hidden partition, and you can have completely different contents within the 2. Where this could be useful is if for some reason you're forced to give up a password and show the contents of it. Hopefully you don't get in these kind of situations, but what you could do is you could just provide the password to the hidden partition, and unless they're looking very carefully, it's quite likely it's never even going to be noticed that there's actually something else there. Although there are ways to actually somewhat notice it. Okay. So here are the parameters for the hidden partition that I'm going to create. First of all, there's an eye catcher, somewhat of a secret, but not a secret. So the eye catcher I'm going to use similar, so I can use a regular expression that gets both, but it's not a secret. Okay. But there'll be things like passwords created with this, which are kind of a secret, kind of not. We don't want them actually leaking around. Okay. The location of this hidden partition is actually going to be within the encrypted file that I created in the previous step. And it's going to have a completely different password than what the regular encrypted file had for that partition that was done in the previous step. And that different password is what will trigger the thing when it gets opened, mounted, as to whether it's going to go into this one or go into the other partition. And in this case here, I'm not going to take a lot of time to actually populate the thing. but I will mount it to the F drive. I'll create a directory, and then I'm just going to use the echo command to create a file, and that contains not a secret here. Okay, so let's jump on over to the VM. Okay, and very similar here, we do create volume. Okay, next. And instead of the standard, we're going to say we want a hidden one. And we're going to select this direct mode because we've already created the outer that it's actually to go into. Okay, next. Okay, so it wants to know the location of that outer file where we created, that we've already created. So documents here, and there he is. And we open him. Okay, next. Then it needs to know the password for the outer volume. I have to go back and look up again. Okay, so the password for the outer volume display, that's what we created in the previous step. Okay, next. And okay, so we do the hidden volume, standard encryption math. So we have to pick a size smaller than what the outer one is, and I'm going to choose 20 megabytes here. Okay, display password. And so for the hidden volume or the inner volume here, the password is okay. And then again, we need some randomness. And really don't care, so I'm even going to format it even before, while it's still in the red. Okay. Next. And we are all done with that. Okay. So let's go back to the, we'll mount that thing at F. So mount. Okay. Now in this case here, I could actually give it either of the passwords, either the password for the outer one, which would give me the contents of the secret contents I already had there, or I can give it of the hidden partition. In this case here, I'm going to give it the password for the hidden partition. Okay. Oh, come on. There we go. Okay, so now it's mounted. I can use cygwin. And it will be mostly empty, just that volume information thing there. And then I just need to come along here and Okay, telling it where to redirect it. Okay, I've now created the contents of the hidden file there. Real quickly, we've got a file here by that name. It's 23 bytes long, and I can display its contents. And it just contains a single line, not a secret, and a magic number. All set here. Okay. And then if I want, I can dismount that. Let's go back over to H drive. Just going to demonstrate how this all works here. So when I come here and I mount, display password here. Okay, so you can see what I'm doing. And just as a demonstration here, I will give the password for the outer here. And we'll just use File Manager here to go look at it on our H drive. And there we go, the secret directory with all the secrets in it. Okay. Now we can dismount that and just tell it to mount it again. But this time I give it the password for the hidden partition. So it'll soon be mounted as drive letter H. And this time, because I gave it the hidden password, the password for the hidden partition, instead of mounting all those secrets, it should actually just mount the not a secret file, the hidden partition there. Okay, here we go. And as before, this PC, drive H, there's the directory, not a secret, and there. Okay. So the way this works is when I hit mount, I have two passwords here, one for the outer, one for the hidden, and depending on which password I give, I get different contents. So far, I've created a regular encrypted file that contains an outer partition that can be mounted, and within there a hidden partition. Although that does fairly well at actually hiding some of what's being done here, it's actually moderately easy to notice these. So if we go on over to the virtual machine and we simply look at the file manager here, we will see under documents, there we've got the VeraCrypt volume there with the .hc extension. It's a moderately large file, and we'll even use larger icons there. And there we go, it's 100 megabytes, and it's sitting there, pretty good icon that really shows what's there. Now, the VeraCrypt documentation actually mentions that you can actually change these extensions to pretty much anything you want. So for instance, well, 100 megabyte video, that makes sense. And I'll just go ahead and change it. That says it's a video file. But actually, in some ways, no, it's pretty easy to notice that really this is not a video. For one, it uses a canned icon here. If I double click on this thing, because it's really not a video, it's going to have a little bit of a problem playing it, and it can't play it. This is somewhat to be expected. Let's contrast that with the way videos normally work, on this Windows machine at least. Here are two time-lapse videos from the U.S. Air Force Museum in Dayton, Ohio, that I took a while back. We can see the first frame of each of the videos shows up there. This one here's 301. It says megabytes. Actually, this MB there should be MIB. That 301 is hex megabytes. We can actually see the real size of that file exactly. Coming down here under properties. And here we say it's 301. That should be MIB. And then this is the actual value in decimal. It's 300 and slightly over 315 decimal bytes, million decimal bytes. That 315 is going to be important. What I'm going to demonstrate here is a technique of actually appending the VeraCrypt volume to the end of this video. Now, it would be a little challenging for me to go around and remember this exact byte offset. So I'll round the 315 up to 320. And I'm going to use some cygwin commands, some standard Unix commands to actually append that the VeraCrypt volume to the end of this video. So let's jump on over to cygwin. Get rid of him. Okay. So jump on over to documents. And there's the volume down in the end. It still has the .mp4 extension, so I'm going to move that back to standard extension. And just so I can demonstrate that I'm able to get rid of this and then get it back, I'm going to generate a real quick checksum on this thing. And here we've got the checksum. It starts with 44, able 8AA 769. We've got some more characters and ends with 6C5. Okay, so there that is. So to get started with this, standard Unix command for kind of moving data around is a command called dd. We tell dd where the input file is, the input data. And that's going to be our VeraCrypt volume. Okay. Then we want to tell it where we're going to send it to. And I would want to be very careful that I do not hit enter right here, because that would actually take that input file, write it right over top of the beginning of that video, which would kind of destroy it. So I actually need to get it put at a very specific location. So I'm going to work in 1 megabyte blocks. And I'm going to tell it, before you start writing this on the output file, I want you to seek in the output 320 blocks. So it'll have a seek location of 320 megabytes. So I come along and we let that run very quick. And now if we come back to File Manager, we go back to videos, we look at our initial video there, it regenerated the first one there. We look at properties. He has grown a little bit. He's now 405 megabytes or so, 424 decimal, grown there. The thing is, though, it really did not bother him. This will not work in all file formats, but it really did not bother this video file format at all. This thing's playing. You can still seek into it wherever you want to go, and it really has no troubles there. Okay. So at this point, I can actually take and remove the VeraCrypt volume. Okay, so it's now gone. If we look at the documents here, it's no longer present and fairly well hidden at the end of that video. Now, we do need to be able to easily get it back, and that's actually done by just using the dd command, but kind of in the opposite direction. So in this case, I take dd, and the input file is going to be Oops. Sorry. .mp4. The output file is going to be right back to where I want it to be. Okay. Work in block sizes of 1,000,000 decimal bytes each. But instead of seeking on the output file, I'm going to skip on the input file. And I have to put in the same skip location that I remember for this video. I put it at 320 megabytes. So I do that. And if I regenerate the sum for the volume, we're back to having the same exact MD5 checksum that we had before, all back there. And if I want to, I can now demonstrate him by coming back in here to VeraCrypt. Oops, how did he come up? Sorry. Okay, that thing's there. Tell him to mount it. It's to display the password, and I'm going to give the password this time for the hidden volume. Unfortunately, these hidden volumes always take a little while to mount, a little bit longer than the outer one time. But it very soon will get mounted here as drive letter H. And there we go. And we take, and we've got our VeraCrypt volume back, this PC, drive H. There's the not a secret folder, and there's the not a secret file. Up to this point, I've created a regular file, encrypted file, that contains both an outer partition and a secret partition. Plus, I use some steganography techniques to take that encrypted file and append it to a video. In both cases, all of the secrets that these files contain, the file and the copy of the file contain, are all encrypted, and everything should be good if nothing has accidentally leaked out to someplace. Now, actually, in doing this demonstration, I intentionally made some mistakes, just so that in this section I can actually show the mistakes that were made intentionally, and we can discuss some of the edge cases here and why they occurred. So to actually find all of these secrets, and who knows, maybe there are other places also, but we're going to actually do a fairly extensive search for any of this secret stuff. We already earlier in the setup talked about this strings match script, which takes an extended regular expression in the name of a file and will actually run strings on it and will spit out some information, the file name and anything that matches the regular expression. If there are no matches, then it just puts out nothing, no file name, nothing matches. So ideally, we'll just get a bunch of no output. But when things do leak and it discovers them, we'll get the name of the file plus the contents of what actually did leak. Okay. We need to run that on actually every file, at least every regular file on the entire system. Now, to do that, and it's going to take a while, I use time to actually find out. That's a program that'll tell me how long this all took. Last time I did this, it took slightly less than 6 hours, and I made some changes to the script, and I'm actually suspecting it's going to take a lot longer than that. So this find here from cygdrive, this is actually kind of like the root of everything, and all of the mountable drives, all the drives that are mounted will show up as different letters here. So there'll be cygdrive/C for the root of the C drive, okay? And if I had a VeraCrypt volumes mounted at like an F or H drive, then I get a cygdrive F or a cygdrive H here, okay? Dash type F is telling me that the regular files I'm only interested in, And unfortunately, some of these files might have spaces in their file name, so it's just something I need to know to do. This -print 0 -null, that combination of the two things kind of allows spaces in file names. All of those file names get piped into this program called xargs, which is actually going to run whatever program I specified here, that strings match script, on each one of the inputs. So it'd normally be each of the lines, but it's because of the print 0, it's everything that's separated by a null. It's going to run it, and the -n1 says one at a time. It usually, without that, it just puts as many of them as it can, but strings match can only handle one at a time. That's one of the reasons it takes a long time to run this. And here's the regular, it's an extended regular expression that we want to find. So we want to find anything that has the word secret in it, and then 4 equals for the end there. This question says 0 or 1 times. So 0 would be of whatever's in front of it, and that's the not A. So if it's 0 times, then it'd be 4 equals, secret, and 4 equal signs. If it got it 1 time, then it'd be 4 equals, not A, secret, and then 4 equals. So it'll find both of those and send them on out. Okay. And this is going to take a long time to execute. So let's jump on over to the VM. In some ways, just to cause some difficulties, VeraCrypt right now has nothing mounted. So the encrypted volume with the secrets in it is not mounted, so it should not show up anyplace. But I am going to leave the VeraCrypt program up here, and hopefully, and I'm fairly sure this is true, it hasn't tucked those passwords away in any temporary file or something around. Okay, if it did, then it's going to be discovered very quickly here. Okay. So I need to run this perform find secrets, and I do that from a cygwin terminal, but I can't use this terminal because if I look at the ID here, well, that's interesting. There it goes. I'm not sure why it wasn't taking that immediately. There we go. It is this IE user, which was the default user account for this evaluation version of Windows. The groups here, there are various groups here. The main one is it does not have the administrative group, so there's a bunch of files it can't get to. So I want to get out of this terminal, which is not that useful to me. I'm going to right-click on cygwin terminal, and I'm going to say run as administrator. Okay. And there he is. And this time when I do ID, you're going to see here, where to go, the group, account and member of administrators group. Okay, and there's administrators. So this terminal now has a lot of permissions. It can basically look at all of the files now on this system. Okay. So at this point here, what I need to do is I mostly just need to run that script that I talked about and then be very patient. I need to take all of its error output and send it to normal output. This is just some shell syntax. And I'm going to send all of that output into a file. This team will actually send it to the screen and send it to whatever file I specify. So I'm going to say the file. Okay. And press enter. And so far, because I've got no output there, it hasn't found any problems. But this is going to need to run a long time. This is running. I'm going to now jump into going to let it run, and you're going to see a fast forward, and that fast forward is going to be a significant number of hours. Although it took 624 minutes or 10.4 hours, we're back with the perform find secrets completed here. The reason it took a long time is a lot longer than the 6 hours it previously took is that previously I had used a -P4 option with xargs, which said I could run each of the xargs items up to 4 times in parallel, but there was some MP locking issues where the results didn't come out consistently. So I needed to get rid of that and run all of this serially. So it actually did take quite a while. more than 10 hours for this to complete. But it has completed, and we do have some output. So it actually did discover the secret eye catchers in various locations. We can actually find out how much it actually found, how many files it found it in, through the output of this following command. Remember that each of the eye catchers, each item found, it starts with at the start of a line, that's that caret symbol for regular expressions. We'll get a line with 4 dashes, space in it in the output file. Okay, and if I take that and I just count how many lines of output do I get, I've got 11 lines. So basically there were 11 regular files that were discovered with the secret or the not a secret eye catcher. And we can actually get the actual file names right here. So for example, there's a file, sig drive c cygwin64 home IE user bash history. This is actually a file by default that the bash shell creates and maintains command line history in it. Fortunately, this file, if we look at its permissions here, we see this RW dash, then dash, 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 dash. The first RW dash means that the user, i.e. user, can read and write the file. But the next set of 3 dashes and 3 dashes, those would be for other people in the group. The group is none. And other people, they don't have any read, write, or execute permission. So besides IE user and processes that can kind of override these rules, like the administrator, they can't look at the contents of that. We can easily, though, go in, because I'm running as IE user, I can easily go in here, look at this file, and see it. We can also see within the output file, it not only displayed that file name, right up on the top here, bash history, it also listed out the contents that it found here. And the reason we have some secrets in here, such as secret, what is it, 3223, redirect out to that file, is because this user in creating this was actually intentionally done, has made a major flaw here. The major user error that was caused here is the user here has actually typed secrets as command line parameters to commands being executed. And then those are being captured into bash history. So we see the secret name of a directory. We see the secret contents of a file being directed out to a file name that's also a secret. Okay. And then we got VI of a file and make dir this file echo. Okay. We can also see here this next place it found it in out find secrets. This is actually nothing to be concerned with here. This is simply a recursion of the perform find secrets things, because every time perform find secrets found anything, it wrote its output to this file, and then later it found that actual output file and it performed the same thing. So it's really displaying just the same thing. Finally, we come down here. Next one here we see we've got various things under users, IE users, app data. And these are somewhat of a concern, but also somewhat not of a concern. What these are is you will find cases where things like the file name has been leaked. It's in there. And actually, if I come back and I look at the file permissions on these files, at least by default here, any user can actually read these files. Okay, so this file here, as an example, let's just grab that. That has read, write, execute for the owner, read, write, execute for the group, and then really of a concern, read, nothing, execute, but the read for others. So although there might be some directories, and I've checked and this is not the case, but some of the directories leading to this might block access by other users, at least the actual file is allowed to be read by others. So others can look at this file, look at the contents on it, and see it there. Okay. And then that does have some things that we normally would keep secret, things like the directory names and the file names that are actually within the secret partition. Fortunately, if we look for some of the contents, the secret contents of the file, I've not discovered any cases where these app data files have actually leaked file contents, but the names of the files and directories are definitely being leaked. Okay. At a high level, it took 10.4 hours to do this search. Previously, it only took about 6 hours, but that dealt with this -P4 option that I can't use anymore, at least for now. It'll take some coding, additional coding, to get around some race conditions to have the results come out. These are the 11 files that it actually found them on. There were no detected cases of leaked passwords. That's good. Okay. Secrets leaked to bash history, those were basically because secrets were typed in on command line arguments. This is usually considered a user error, but good to demonstrate here. Okay. And then the secrets shown in outfind secrets, that's a recursion thing of, it's just a holdover from the actual process of finding and recording the secrets that were found. All of the remaining leaks were found in various users, i.e. user app data files. Okay. There was no discovered leaks of any file contents. There was, though, significant leakage of directory and file names, which may be considered an issue or maybe not. But you could actually discover quite a bit by just looking at a user's various app data files as to what applications and which files and directories they've been in. So far, it's been demonstrated how to create a VeraCrypt regular file that contains an encrypted version of a mountable partition. Plus that encrypted file can also contain a hidden partition, which is another partition within the same file there. And depending on which password you give, it will mount either the outer or the inner partition. This works fairly well at creating these partitions and having the encrypted data, but also in the previous section, it was demonstrated how it's very easy to have secrets from those partitions leak outside of the partition, either because of user error, such as specifying a secret on the command line and then that being saved outside the partition, or sometimes the operating system or applications will save various activity and history information, such as the names of directories and files that the application has opened, mostly to make it easier to find them, again, for the future, and have various enhanced UI tools that can look at the stuff. But those are secrets that you may want to not leak. You can actually frequently gain a lot of information just by knowing the file names and directory names that were used in, within the encrypted partition. In this section, I'm going to demonstrate a way of circumventing pretty much that entire problem. And the method is to actually encrypt the entire system partition, so the bootable disk on the disk. That way, if an application or a user error, but for whatever reason the information leaks outside the partition, as long as we're not leaking it out across the network, that would be quite a problem. When it gets written into those history or activity files, they're actually going to go onto an encrypted disk block. One downside is every time you boot this thing, you are going to have to give a password so that it can actually then access the fairly strong key that will actually allow decryption, encryption of the disk blocks. Okay. For this demonstration, I'm going to need another password. So for this demonstration, not a great password here, but just for demonstration purposes, I'm going to have an eye catcher and then a 4-digit number, just as I did in the earlier sections. Coming on over to the virtual machine, we'll get started here. Okay, just as it's been left there before. We don't need the cygwin terminal for this, So go on out of that. And you'll note here in the VeraCrypt application, you'll see there is no C drive. That's actually the system drive. As we actually do this when we get finished with this, when we come up here, we are going to see the C drive. And we're going to see that it's encrypted. Okay. So we do create volume. But instead of doing this create encrypted file container, okay, or this would be used to encrypt things like USB drives, we're going to come down here and do the encrypt the system partition. Give it permission. Okay. So normal, there we go. Encrypt the Windows system partition. In this VM, it's a single boot. I don't have multi-boot. Okay, and I'm just going to take defaults here. Then we need to tell it the password. And this is going to be a password you would want to have fairly strong, and you'd want to have something you can memorize. We are going to create a rescue disk in case things go bad later, but the rescue disk is not going to work unless you know this password. Although this is not the password that the blocks will be encrypted and decrypted with, but this password will then allow the system to access that longer, stronger password. Okay. So and okay. Now it's going to warn me that this is not a very strong password, but this is only for the demonstration. Okay. Just as for the other encrypted file, moving the mouse around is generating some randomness. Okay, this is going to be the real key that it's generating right now from my mouse movements, that it's actually going to encrypt and decrypt the disk blocks with. Normally you do this until this at least becomes yellow, and quite likely this is important enough. You probably have this become green. For this demo though, I can do the next even while it's still red. Okay. Okay. If I want, I could display it. Unfortunately, it doesn't show the whole thing, but I'll have later options if I really wanted to see those keys, what was generated there. It's going to create a rescue disk. This generally, you'd put this on a USB drive and you would keep this very safe, locked up in a safety deposit box or something. You would very well protect this. When I click next here, it's going to create a zip file. And that zip file is going to have the contents of what I need to put on the rescue disk. And it's actually going to verify that I have done that. I can't just skip through this. So I need to insert a USB drive at this point. I've already prepared an empty one and put it in the NAS. So all I have to do is come on over here and connect it. Okay. It's going to warn me that I'm taking that drive away from the NAS right now. Okay. And any moment here, it should find it. There it is. Okay. So under Documents, there's the NAS, which is actually good. Oh. Okay. The USB drive is right here. There's the USB drive, and right now it's empty. Okay. And then what we have here, I took the defaults of where to put it, and under Documents, I have this VeraCrypt Rescue. I'm going to right-click on that, and I'm going to tell it to extract the contents of that zip file to the USB drive. PC, oh, there it is, right there, to the E drive. Okay, extract. Now at this point, well, you see the EFI there. Is pretty good indication this is a bootable drive. Ideally, I could eject that drive right now and tuck it away safe. But what I really need to do here, somewhat important, is I need to let VeraCrypt, actually I need to prove to VeraCrypt that I've done what it told me to do here. So with the drive still mounted in there, the USB drive, I'm going to click Next. and it verified that, yes, I have successfully created that rescue disk. Okay, so at this point, please remove it and store it in a safe place. Okay, so come over here, let's eject it. Okay, it's safe to remove it. We'll come over to the VM, and I'm going to eject it from that VM. Okay, the VM no longer has access to that drive. And I would normally now pull it out and save it someplace very safe. Okay, next. Okay, wipe mode. If you're doing this on a brand new machine that you've just purchased, it's got a brand new hard drive, you probably use this none formatted. Otherwise, you're going to want to make sure that you get rid of the blocks. And there are some lab attacks where they could actually open up the disk drive and put it into special machines that can actually find data that has been written, blocks that have been written over a number of times. And so one way around that is you just simply write additional random data over the block multiple times until finally it's done it enough times that basically, even with some very sophisticated equipment, it's highly unlikely that you would get any of the old data. For this demonstration, I just do the none faster. And even then, that is going to take a while. So it's going to do this pretest here. Okay. And we've got this, and it's basically instructions for how to use the rescue disk. And if you can, you want to print a copy of this and keep it with the rescue disk. Now, with that rescue USB drive, you still need to know the password that you typed in there that then gives access to the password that was generated with the random mouse movements. Okay. And now it needs to restart my computer. Okay, well, let it get going here. The system's coming back up now. And in this case, to access the boot drive, I now need to give the password so that I used to create this encrypted system partition. In this case here, for this demonstration, the password is 4 equal signs, the word secret with a capital S, 4 equal signs, and then 1374. Okay. And this PIM thing for now, we'll leave that empty. And now it's doing the authorization. Okay, success. It's now got the disk blocks and it has access to them, and it's going to continue on booting. Okay, all logged back in, have booted back up, all logged back in, and I'm going to start up the VeraCrypt app. Come on, go. There it is. Okay, now if we look here, we now see the C drive, system partition, but it's only 0% encrypted here. So this did come up fairly quickly here, but it has actually not encrypted the blocks yet. Okay. And this warning message here is because I brought it up while it was actually up there already coming on up. Just let us snuck in. We'll close that one down, come on the one that was here. And now we're going to start a process here of actually encrypting those blocks. So I click encrypt. It's going to give me the instructions again for the rescue disk. If possible, you want to print that and keep it with the rescue disk. And then we've got this here. Oh, come on. You're going to see this mouse here with a little time lapse thing here. So it looks like you need to click encrypt. Unfortunately, it's non-responsive, doesn't show the progress here, but just be patient, and finally you are going to be able to come in and you're going to see it working. Okay, so for right now, I don't have to do anything but be patient for a couple minutes here. As indicated, after a couple minutes, it was probably closer to 5 minutes, the mouse icon stopped having the little spinning weight wheel, and then now it actually shows the percentage of the drive that has been encrypted, its status. It's currently encrypting. And for this, which is, so I recall, this is a 40 gigabyte drive that this VM has. It's going to take it about a half an hour to do that. Okay, just about done encrypting the entire system partition. Just a few seconds left here, at least by the status display. But we will see very soon here. We're going to hit the same situation we had near the start here. We're going to get the little mouse here with the little spinning wheel thing. And this is actually going to last for a few minutes with no status update. Just something we have to be patient with here. So just be patient. Okay, after about 5 minutes of the mouse with the spinning indicator on it, and really no progress indicator of what percentage, but about 5 minutes of that, we finally come up with a message, confirmation that the VeraCrypt volume creation was, that system partition successfully encrypted. And we'll just come here, close this down, bring up the regular VeraCrypt application. And this time when we do it, we see again the C drive here, but no message here for that. It's only been partially encrypted. By coming and viewing the volume properties, down on the bottom here, encrypted portion, 100% fully encrypted. So that completes the demonstration of how to create an encrypted system partition. In summary, during this demonstration, I demonstrated how to download, install VeraCrypt, create and mount a partition within an encrypted regular file, how to create and place a hidden partition within that outer encrypted regular file, using some steganography techniques, hiding techniques, just demonstrated how the encrypted regular file could actually be appended to the end or of an existing video file and later extracted on demand. Further went on to demonstrate how to search the entire system for known secrets to see if they've escaped at all from the from an encrypted partition, and demonstrated some use cases, some cases where that actually did happen. The most serious cases being from user error of a user who, as I did for this demonstration, intentionally typed some secrets on the command line, which then escaped into some histories. Also found some cases where either the operating system or applications running on the operating system were saving history of file names, directory names that were encrypted from the encrypted partition to places outside, mainly into the user app data area, into files that actually are readable by everybody on the system. So it would be easy to find that. Finally, demonstrated how to minimize much of this potential problem of things escaping either through user error or through other mechanisms by actually encrypting the entire system partition.